Let's talk properties of cones. A cone, a three-dimensional figure that has one circular base and the side, right? So if we have a circular base, that means we have ourselves the radius. And if we would go all the way across, the whole thing across is the diameter, just the same with a circle. The entire piece, then it slants up and meets at one spot at the top. We call this either the apex or the vertex. Both of those are considered correct. And again, the circle is the base. Now, we have two different types of cones that we talk about. This first one we would call a right circular cone. Now, this simply means that if we would drop down a height from the apex to the middle, it would form a right angle with the diameter. That's what it means to have a right circular cone. Whereas the other one here, posted on the right, is an oblique cone. So it's an oblique cone because it kind of goes off to the side. If we would drop down a right angle to the base, you can see that the right angle in this height, right, this would be the height of the cone, falls outside of the cone. In a right circular cone, the height drops down inside of the cone. With an oblique cone, the height falls outside of the cone. And that's kind of the big difference in terms of what they look like, right? You can see the oblique cone is like, it's like it's fallen over. Think Leaning Tower of Pisa if it happened to be a cone, but that's an oblique right circular. That's the big difference. The key, both bases are circular, whether it's a right circular or an oblique. They have a circular base, they have a height, they meet at an apex, and properties of cones.